So here we are trying to understand the basic idea behind distance formula. So how do you figure out a distance on a coordinate plane is what we're looking at. So we begin with a simple scenario. So all the points are on the axis, and I want to find distance like A to B, Mn, not cross between all of this. I just these are quite simple. But thing is, if you are able to answer this, you pretty much will be getting the distance formula itself, right? So the procedure is this. Write the coordinates of the above points. Next is count, right? If you want to find the distance from A to B, count. Once you start counting, try to recognize some pattern. Like how can I make use of the coordinate geometry, basically, coordinates of the points. And at the end of it, try to kind of derive a formula. Okay, so you can pause now and start doing. Have a look. So now let's start with A to B. How do you find A, B? Oh yeah, first is coordinates. Let's write down the coordinates. B is 5, 0. That is 5 units to the right, but we're not going up and down, so it's 5, 0. Point A is 1, 0. Make sense? 1 towards the left, right, and not up and down. Minus 2, 0, indicating it's to the left. And minus 4, 0. And then you have up and down values. That is 0, 1 and 0, 4. And we have done 0, minus 1. So these are your coordinates. Once you know the coordinates, you just have to, we'll make use of it somehow. So let's start counting. A to B, 1, 2, 3, 4. 4 units. If someone got 5 units, I'll explain why is it not 5 units. So it's something like this. If you want to go from point A to point B, right, which is certain distance away, okay, a particular distance away. The thing is, you don't start counting from that point itself. You won't be like, okay, I traveled, you're standing over there, and you won't tell I traveled already a kilometer. It's not like that. Once you go a kilometer, you tell, okay, I went a kilometer. So the count is always 0 over there. You covered 0 kilometers. This is your first kilometer, second, third, fourth, and fifth, so on and so forth. So in this case, it's 4. So I covered 4 kilometers, right? So similarly, find what A, C. A to C will count 1, 2, and 3 units, and you are there. Then AD 1, 2, 3, 4, 5. 5 units. DC 1, 2, 2 units. MN 1, 2, 3 units. MP 1, 2, 3, 4, 5 units. NP 1, 2, 2 units. Did you recognize any pattern? Matlab, this is too hectic. I mean, I don't know why I kept doing it. I should have stopped in the middle. But yeah, I did it. So is there a better way of doing it? Well, we have to make use of the coordinates. How simple. How can I get 4 from 5 and 1? See, we're looking at AB. B is 5, 0 and A is 1, 0. How can I get 4 out of 5 and 0? Because, and sorry, 5 and 1. Anyways, this is 0. So we are not thinking about y components. We're just thinking about the x components. So this is 5, 5 minus 1. A to C. 1 minus of minus 2. 1 minus of minus 2. A to D. 1 minus of minus 4. Right? It's that simple. What am I doing? I'm just subtracting the coordinates. So when you do this, I'll get 4. When I do this, you get 3. When we do this, it is 5. DC. Minus 4, minus 2. Minus 4, minus of minus 2. But you got minus 2 over here. So there might be a, no, you will be like, how is this possible? So thing is, in coordinate geometry, when you're talking about distance, you neglect the negative sign. After doing the process, not during the process, after doing the process, you just let go of the negative sign and you end up with a positive value. 0 or positive value is the only, these are the possibilities when it comes to distance in any kind of thing. Either you travel some distance, if not, none. Can't be negative, right? So this kind of thinking is your modulus. It's called as modulus function actually. Modulus operation. Okay, let me put it as operation to you guys. It's just a simple modulus operation. What does it tell? You guys neglect the negative sign. Final answer, you just write it as positive. As simple as that. So the representation is two straight lines like this. Okay, so that you will be studying in the future. So it's just a small introduction. Future in the sense higher grades. Next is MN. So simple. Here we are neglecting x-axis because it's already 0. Just look at y-axis. So 4 minus 1. So this is 3. Okay. MP. So this is 4 and this is minus 1. So 4 minus of minus 1, which is 5 units. NP. 1 minus of minus 1, which is 2 units. And we are done. Right? If you are able to understand that, okay, for this is what the procedure is, then you're done with the entire thing. But please learn to understand the basic idea. If you don't understand this, you won't get anything. Okay, if you're not still getting it, go back and watch it again. If not, try few problems. There's quite a few problems in your NCERT books, not in your present grade, but previous grades. So you can web search that. You can find basic coordinate problems, and you can do this. Right. Next is a scenario, a bit different scenario, not bit, a lot different scenario. We have a point which is not on the axis, but somewhere random, right? Like this. How do you do it? Think about it. You can pause and think. The clue is you have to make use of Pythagorean theorem. So from origin, right? We're finding the distance, that is we're finding OA, this length. To do so, we need to know how much across and up it is. That is basically we are finding the coordinates. So let's write the coordinates. So whatever you do, first thing you do is writing the coordinates. So coordinates here is 4, 3. Here it is minus 4, 2. Here it is minus 3, minus 3. And here it is 2, minus 4. First is to the right and then down. So even I always get confused. So I always think of right. Okay, it is 4. Right or left, basically. So this is left and this is 2 units. Right? So that's how I keep thinking. So once you find the coordinates, the next thing is quite simple. You just have to find, like say this is see, if I do this, you end up with a right angle triangle. So if I know the length and the breadth, hypotenuse is not a big deal to find. But how do you find the length and the breadth? That's the question. See, it's quite simple. It's same as what we did just now in case 1. So if I start take one of this as a starting point and this as the ending point. Let me show that properly. If I take this as a starting point and this as the ending point. So what is the length? 4 units. If I take this as a starting point and this as the ending point, what is this length? 3 units. Is it not? So that's the whole idea of the coordinate representation. So once we know, finding OA is not a big deal. So OA square is equal to, if I call this as P, Pythagoras theorem, I'll just write it for one of it. AP square plus OP square. So this is nothing but 3 square plus 4 square, which is nothing but 9 plus 16, which is OA square is equal to 25. And now OA is equal to 5 units. Okay, we found OA. Next is OP. So here again, we are looking at, we wrote the coordinates. We learned the basic idea. Now we have to start looking at the pattern so that we do it fast. So OB, we need to find OB. So let's think about it. This is 4, 2, and this is from the origin. So here 4, 3, we did 3 square plus 4 square, and we got the answer. I mean the square of it, and we took a square root and we got the final answer. So what can we do over here? Right? We just have to square 4 square plus 2 square. So this is 16 plus 4, 20, and therefore OB is equal to square root of 20. I'm not further reducing it. I'm just letting it be. We can further reduce it, and it has to be generally. That's the rule. So we have root of 20 units. And I hope you got the idea. I mean, you guys got the idea. So how do you find OC? We know the coordinates. All we have to do is, right? And this is 9 plus 9, that is 18. So OC is equal to square root of 18 units. Next is OD, 2 comma minus 4. Quite simple again. OD square is equal to 2 square plus minus 4 square. 4 plus 16. So this is 20. Therefore, OD is equal to square root of 20 units. Right? So this is the basic idea. A bit more complicated version. Right? We always thinking about what is the next version or how do we go about doing it. So next is the bit more complicated version, and that is taking two random points. So what if I don't have this? What if I have just random points, like A and B? How do you figure out A? Distance from A to B. If not A to C or B to C, so on and so forth. How do we do this? Here too, it's the same thing. We need this your hypotenuse, and we have a right angle triangle. And if you know the length and breadth, we are looking at the answer. Okay. So how do we go about? We're looking at the idea of projection again. So we are projecting point A and point B onto our x and y axis. Okay, so let me show that properly. It's not visible here, but right. We have to project the x and y axis. So we are projecting. We are seeing, okay, along the x axis, where is it? Along the y axis, where is it? So basically, this is a rectangle, is it not? If you think about it. So this length, AP, will be equal to A dash, P dash. And this length, PB, will be equal to P dash, P dash. So how do you find the distance along the x-axis? We subtract them. So 9 minus 3, it is equal to 6 units. Right? Modulus of it. Okay, modulus means you don't need to think about the signs, you just subtract it. And next, think about PB. In this case, P dash P dash. How do you find that? Again, this entire thing is a rectangle. So opposite sides will be equal. So finding B dash P dash is same as finding BP. So how do you find B dash P dash? 7 minus 2, that is 5 units. So once I know that this is 6 units and this is 5 units, finding AB is not a big deal. So again, first we are looking at okay, the coordinates 3, 2. How will that help? We'll see. Point B is 9, 7. So in a coordinate geometry, first look at the coordinate. Doesn't matter if you're using or not. It's something that we need to look at. Right? So we know the coordinates, then we found the length and the breadth of the triangle APB. And now all you have to do is use Pythagoras theorem. AB square is equal to 6 square plus 5 square. So 36 plus 25. So 50. And this is 60. Wait, what? 50, 16, 66. So AB is equal to square root of 66 units. Okay. So this is square root of 66. Now A to C. Sorry, A to C. So how do we go about AC square is equal to? Now think. How do you find this and this? Not with the help of whatever we did now, not with the help of projection. The projection idea is by default there in coordinate geometry, but try to think. So basically we're looking at how across and how long it is, right? How across and how long. How do you find it without the use of all this, to if I kind of erase all of this rubbish as of now for you guys. So now it's a clear picture. How do you find A to C? Basically, you need to find this distance and this height and use Pythagoras theorem. So all you have to do is finding across. We call this as P, CP and AP. How will you find it? Right? Simple. C to P is nothing but 3 to minus 1. What is the distance from 3 to minus 1? 3 to minus 1 is 4. So basically, can I write it as 3 minus of minus 1, the whole square? Because, well, let's at least present it nice. And A to P, 2 to minus 1. So it will be 2 to minus 1, the whole square. So this is 4, this is 16, plus 9, 25. So AC is equal to square root of 25 units. Right? Next is BC. Okay. So think of the same line. You have a point 9, 7. We have to find, the distance BP. So again, we are looking at how across and how long it is. Across, we are looking at from 9 to minus 1. And height, we are looking at 7 to minus 1. So 9 to minus 1 is what? 9 to minus 1 is 9 minus of minus 1. The whole square. Plus height, it is 7 to minus 1. So 7 minus of minus 1, the whole square. So this is 10 square, that is 100, plus 8 square, 64, 164. So we have BC is equal to square root of 164 units. And this is your answer. Okay. So I hope you guys found the basic idea. That is, all we have to do is find the distance across and along and take this, use Pythagoras theorem. That's the whole idea. And now to conclude the general form. So now we are looking at distance from point A to point B, whose coordinate is x1, y1 and x2, y2. Right? So looking at this length and this length, right, to find A to B. If I call this as P and this is 90 degree, okay. So we're looking at the distance A to B. How will we find it? Now we have to think, because logically I told everything is just variables. So first step is we will find A dash B dash, and we need to find P dash B dash, the length. How will we do that? At least now think about it. So we'll do it by subtracting x2 minus x1. And here we'll subtract and find out that this is y2 minus y1, right? So basically we got the length and the height. Base and the altitude we found, and finding the hypotenuse is not a big deal. So AB square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square, right? Pythagorean theorem tells the square of the hypotenuse is equal to sum of square of the other two sides. And thus this is your distance formula. The reduced form will be AB is equal to square root of, right, this entire expression. Okay, and that's how you find the distance between 2 points. This is the general formula. I can directly use this. Whatever I just did now, it's conceptual, nothing else. So now let's revise whatever we just did. So first we looked at the idea of finding distance along the x and y axis. And we saw that this basic idea continues, and we have the final answer, right? So 5 minus 1 will give me 4, and that's the distance between A to B. That's as simple as that. And if I want to find B to C, it will be 5 minus of minus 2, which is 7, right? B to C. Okay, so this, if you understand, you are done. Next is we found from the origin, like origin is 0, 0, and this is 0 to 4, this is 4, and this is 0 to 3, this is 3 units. Since we have 3 and 4 units, finding the hypotenuse is not a big deal. And then we looked at finding the distance from A to B. So here we used again the idea of projection. Okay, so we made use of this. So we found that, okay, from 9 to 3, 9 minus 3, this is 6 units. And yeah, and this length, this is 7 minus 2, 5 units. Is it not? So it's as simple as that. We are subtracting the x and y components and getting the height and the base and the altitude. Once you get that information, all you have to do is find the hypotenuse. This is the whole idea. And now, to end with the formula, we have to find this distance. For that, we project these points onto the x and y axis. Right? And you find the length and the altitude, the base and the altitude. And using Pythagoras theorem, you find the distance. So this is the basic idea.